Hello students, in the last class we have discussed about the chapter 2 elements and compounds. Now we will discuss chapter 3 mixtures and separations. Before going to the topic, can you please tell me what is matter? As we have discussed earlier itself, matter. Matter. Everything in the universe around us is a matter which having some space, isn't it? That is a matter. We all know about that matter. Got it? Whether it is living or non-living things. What are living things? Living nothing but living matters like humans and animals, etc. Plants, isn't it? Etc. What about non-living matter? Pens, books, elements, compounds, everything, whatever you want you can take. For chemistry, no, so I am taking elements, compounds, like that. Got it. In the last class, as we discussed about these elements and compounds, these are also non-living matter, isn't it? So these are the non-living matters. So what are, now we'll discuss about this non-living. Okay, non-living matter. These non-living matters, will take two examples for this. Okay, to understand the topic we'll take two classification. Okay, to understand the topic I am saying, students. Okay, pure substances, nothing but elements and compounds. Example for pure substances are elements and compounds. Okay, mixtures, got it. Mixture, what is mixtures? Nothing but two or more substances mixed together in any portion that they do not undergo any chemical change and retain the individual properties, called a mixture. Nothing but these mixtures, suppose you can take two or more substances. Suppose if I take some zira, cumin and some dal, like that you can take. These are all kitchen properties, no, which we can use in daily in our kitchen, isn't it? Dal, zira, cumin, mustard seeds, these are all two or more substances we have to take in any proportion, nothing but in any measurement you can take only for some you can take some proportion of these substances. Okay, they do not undergo any chemical change. These zero, cumin, dal, mustard, these do not go any other chemical change. Okay, they retain their individual properties, nothing but this zero has their individual property and dal has this individual property, cumin has this individual property, and whereas mustard has the individual property, and whether pure substances has these individual properties. Okay, these do not go under the chemical change. Okay, so this is called as mixtures. Okay, this is called as two or more substances mixed together. You can mix all these together in any proportion. They do not undergo any chemical change. This is called as mixture. Some examples for mixture: soil, air, petrol, mud water. Okay, for pure substances, elements, and compounds, as we discussed in chapter 2. Here I am taking example. This I am saying for only to understand the topic. Okay, this is called as mixtures and separations. Okay, this is the mixture definition. For example, air around us is a mixture or not? Yes, air around us is a mixture. Why air around us is a mixture? Because air contains oxygen, nitrogen and carbon dioxide and many other gases, isn't it? Is Can I take example for this mixture? Isn't it? Air contains oxygen, carbon dioxide and nitrogen, isn't it? This is the best example. Okay, most of the product obtained from plants. Okay, for example, for plants or for animals, from plants. If I take from plants as an example, from plants, can you give me example for plants in a mixture? Wood. We can take wood as a example from plants. What about from animals? We will take milk. Milk is also a mixture. Nothing but we will add some sugar. Okay, to drink milk and some energy powder. We can add this, no? Some energy powder also we can add. From animals we can take a milk, and from plants we can take a wood as a best example for the mixtures. Got it? Hope you understand this video, Nana. Now we'll see some other examples. As we know that we studied in the last chapter, chapter 2, elements and compounds, isn't it? From elements and compounds we'll take now. Okay, elements and compounds. Okay, iron will take, iron and sulfur. Iron and sulfur from elements and compounds. What are these? Elements, isn't it? These are the elements. Okay, let's mix them. Okay, we'll mix this iron and sulfur. Okay, what will happen? In any ratio you can take. Here I told you, no, mixture in definition, two or more substances in any proportion we can take, and that do not go any under chemical change, retain it to their individual properties. This is called as a mixture. Now we'll see iron and sulfur. We need to mix them. Nothing but we'll take iron and sulfur in any proportion. We'll take. Okay, mix it. What happened? So iron has their own property and sulfur has their own property. By mixing them also, for mixing them in any proportion for iron and sulfur, that does it loses its own property? No, it doesn't lose its own property. It remain stable, isn't it? It doesn't lose their property. What happened? For iron I have one property, magnetic property for iron. Okay, for iron we have a magnetic property. So can be separated by applying suitable methods, okay, based on their property. So we'll heat both iron and sulfur. We'll heat both these properties. So definitely it will lose its property, isn't it? What we will get? We will get a new product, isn't it? We'll get a new product if you hit both the iron and sulfur, both the elements. What we will get? We will get a new compound, isn't it? After heating, the property are quietly different. Now let's see the differences between the compounds and the mixture. For example, here we'll take two elements, whatever it is, not only iron and sulfur, whatever you can take, two elements, two elements, nothing but dotted one element, and here round some other one element. Now we'll take the compound. Whatever it is, compounds, HCl, H2O, NaCl, whatever it is you can take. Okay, isn't it? This is mixture. We'll take mixture also. Okay, two elements. For example, two elements I have taken here. To understand this, I have kept one as a dotted and one this round small rounded. Okay, whatever it is, two elements you can take. Okay, two elements. This having its own property. Okay, for mixtures, if I mix both them, what it form? Mixture. Okay, we can easily mix it. Then for compound has a binding property, isn't it? For compound it has a binding property. For example, H2. We have two elements here, two hydrogens and two hydrogen atoms and one oxygen atom, NaCl, sodium and chloride. So Na plus Cl, it's a compound, nothing but it has a binding property. But for elements and for mixtures, in a mixtures it is not having a binding property. It remains, we can take in any ratio proportion, it remains in a individual. Got it? This is one of the property, okay, for compound and some compounds and mixtures. Hope you understand this video. Please like it and share it. If you are new to my channel, please subscribe my channel. Thank you.